Question 8, Part A. An aqueous solution of phenol is acidic. Explain why phenol is more acidic than water. Means the concentration or amount of hydrogen ion produced from the phenol is more. So why the hydrogen ion that produced by the phenol is more than water? So it must be a reason. So the most useful answer or the better answer, so you can use the phenoxide to explain. So we know that phenoxide here, one of the lone pair, if you delocalize into the benzene ring, okay, see the lone pair, actually the phenoxide it has a few. So the lone pair on this oxygen, right, so is delocalized into the benzene ring. So we know that when this lone pair delocalized into the ring is less available. Less available means is less likely to bond with the H plus here. Means the H plus is going to be larger amount, because the phenoxide, which is the one that should react and form bonds with the H plus, now this is the lone pair is not available. When the lone pair on the oxygens here is less available, so we actually say that is stable. So that's why we always use stabilized. So the full answer is quite easy. Lone pair on oxygens is delocalized into the ring, which is stabilize the phenoxide. Stabilize the phenoxide means this phenoxide is less reactive and less likely to gain the H plus. That's because stabilized. Part B1. Name two products formed when phenol reacts with excess bromine water. When it's excess bromine water, means all the position, the 2, 4, 6 will undergo substitution. So means this is the first carbon, second carbon, third carbon, fourth carbon, fifth, sixth. So means these three positions will undergo the this substitution to form the 2,4,6 tribromophenol. Means the bromines will be at these three positions. So it's 2, 4, 6 tribromophenol. And of course, this is the electrophilic substitution. The hydrogens that initially with this carbon, these three carbon, now is being substituted and form the HBr. So there are two products, 2,4-tribromophenol with the HBr produced. Part 2. Draw the structures of two isomeric organic products with this molar mass 139 that are formed when phenol reacts with dilute nitric acid. Dilute nitric acid means it will just form 2,4 this isomer. Means it will be 2 nitrophenol, okay, or 4 nitrophenol. So it will form these 2,4 isomers. Why? Because phenol is 2,4,6 directing. Because phenol is an electron donating group, it will always direct 2,4,6. Whenever there is this electrophile approach, so the substitutions for the phenol is always at 2,4,6. And how many nitro groups present? At least we should know. For the phenol, molar mass is 94. The NO2 is 46. So when you sum up this one, is actually 140. And it's given 139. Is because for this nitrophenol, so one of the hydrogens in the phenol already gets substituted, so it's -1. So it's 140 minus 1. So we know that from this mass 139, it should be 1 phenol and there is a one nitro group, okay, bonded to the benzene ring. So means there are is not two nitro group or three nitro group, only one nitro group with the phenol. That's what we can get from the mass. Only one nitro group, and this nitro group it could be 2 nitrophenol or 4 nitrophenol. Right, so just draw these two structure. Part 3, write an equations for the reactions between phenol and sodium metal. It's just like the reactions of the alcohol with sodium. So it will form this phenoxide, sodium phenoxide, and of course it will form half mole of H2, hydrogen gas. Okay, so for the last part, part C, phenol can be produced from the phenylamine in 2 steps. Phenylamine then form intermediate and form phenol. So we know that roughly it can form from this diazonium ion, because we know that phenylamine it can produce this benzene diazonium ion, and this one will undergo hydrolysis and form the phenol. So means the step 1 you should relate to these two reagent, right? So sodium nitrate with the HCl, because when you add these two together, the HNO2 will form in situ, and this one will further react with the phenylamine and form this benzene diazonium ion. So the reagents needed they are sodium nitrate with HCl, okay, and the temperature must be below 10. Why? Because when it's too hot, if it's above 10, this benzene diazonium ion is not stable, it will decompose. So we need to make sure below 10, then this benzene diazonium ion can be there. Okay. After that, if we want to form phenol, then we no need to really use below 10. So we just warm the solution, or make sure it's above 10 degrees C, so it will decompose, it will form this phenol. So means it needs water, right, and form this phenol. For the mechanisms, actually I already discussed in the previous part here. So the reagents, you just need to know, we need to use this temperature above 10 degrees C with water, then this benzene diazonium ion, right, it will form this phenol. Okay, that's all. Thank you.